Okay, so hello class, welcome back. So in this recording, we're gonna take a look at section 8.2, distribution of the sample proportion. Okay, so this is gonna be the idea for this recording. We're gonna talk about what kinds of distribution when we have the sample proportion. Okay, so describe the sampling distribution of the sample proportion. So before we're gonna take a look at the distribution of the sample proportion, let's give you the definition or the formula how we calculate the sample proportion. So suppose that a random sample subsize lowercase n is obtained from a population in which each individual either has or does not have some certain characteristic. So when we randomly select the sample from the population, and then in that sample, we're gonna get some people that has some certain characteristic, right? Then the sample proportion denoted by p hat. Okay, so this is gonna be the notation. So the sample proportion is denoted by the notation p hat. So sample proportion p hat is given by the calculation of x over n. So the sample proportion p hat is equal the numbers of individuals that have some certain characteristic divided by the numbers of the sample size. So that's going to be x over n. That's going to be the approximation of the sample proportion. So where x is the numbers of individuals in the sample that have some certain characteristic, and then n is going to be the sample size. So we have n is going to be the sample size, and x is going to be the numbers of individuals in the sample that have some certain characteristic. So the sample proportion p has is a statistic, right? So this is the numerical summaries of a sample. So that's why the sample proportion p has is our statistic then. So this is gonna be the statistic notation. That's estimate the population proportion p. So the population proportion we're gonna use in the lowercase p. So p has is the sample proportion, and then p is gonna be the population proportion. So this is gonna be the new notation we have in this recording, right? Or in this section. So sample proportion p hat, and then the population proportion p. So now let's use this definition of how we calculate the sample proportion to answer question number 1. Example number 1. So in March 2018, a survey asking 1,292 registered voters nationwide if they are concerned about climate change. So among 1,291 people that we survey, 891 of them say that they say yes, they're very concerned or somewhat concerned about climate change. So among 1,291, we have 891 people say, yes, they're very concerned. So this is going to be the numbers of people that have some certain characteristic that we want to know, right? Which is they are concerned about climate change. So what is the sample proportion? So what's going to be the sample proportion? So we're looking for the sample proportion of registered voters who are concerned about climate change. So the characteristic, once again, that we want to know or we want to focus on is if they are concerned about climate change. And we want to calculate the sample proportion that show how many people actually concerned about climate change. So in order to calculate the sample proportion, I'm going to use in this formula. So the sample proportion p has is equal x over n. Okay. So the sample proportion p has is equal x over n. So x is going to be the numbers of people that have some certain characteristic. In this case, if they are concerned about climate change, over the sample size n, which is how many people that we survey, right? So the numbers of people who have the certain characteristic is 891 divided by the sample size n is 1,291. Okay, so you might use a calculator to approximate the sample proportion. So we have 891 divided by 1,291. So this is going to be 6902. I'm going to round the answer with 4 decimal place. So we're going to get the answer is 0.6902. 0.6902. Okay. So this is gonna be the sample proportion and how we calculate the sample proportion based on the given formula P has equal X over N. Now let's imagine this, everyone. Now, if you're gonna go back to the population, you're gonna go back to the same population and you selected exactly the same amount of number, which is 1,291 again. And then among that 1,291 people, now you're gonna ask them the same question. Are you concerned about climate change or not? Do you think that you will have exactly 891 people will say yes, they are concerned about climate change? So you might have that answers again, or maybe the answer gonna be different, right? So among 1,291 people that you surveys again, then maybe the numbers of people who are concerned about climate change may be not equal 891. And then the proportion, the sample proportion will be different again, right? And then you repeat that process one more time. You selected another 1,291 people and you ask them the same question. Are you concerned about climate change again? And then you might don't have the same answer, the same number of people that they are concerned about climate change. So that's why you can say that the sample proportion will be different case by case, right? Okay. So the sample proportion is also a variable. Yeah, so the sample proportion is also a variable. So which means that if we were to obtain a different sample, then we would get different sample proportion. So therefore, the sample proportion, it also has a distribution on its own, right? So you're going to repeat the same kinds of question, but with another group of people, then we're going to get the sample proportion different. Yeah, so we're going to repeat that process over and over. So you're going to get different value for the sample proportion. So now we're going to repeat that process again and again, and let's see what's the general answer that we might have it at the end, right? Okay. So assuming that about 42% of registered voters believe that a certain law should be passed. Okay, so that's what we know it. So about 42% of registered voters believe that some certain law should be passed. Now let's take a look at the histogram that we've got provided right here, and let's see what's the conclusion that we might have. Describe the sampling distribution of the sample proportion for the sample size of n is equal 10, 1,000, 50s, and then 100. So in this case, we're going to compare the three histograms. The only thing different is we're going to increase the sample size from 10 to 50s and then 100. And we're going to do that 300 times for each of the case. So for the first histogram, we have the sample size is 10, and we repeat that 300 times. So we're going to get the sample proportion is 0.426, and the standard deviation is 0.160. So that's in the first case when the sample size is equal 10. Now we're going to do 300 times again, and then for every time the sample size increase to 50. Now you can take that based on the histograms over here. We can know that the mean is equal 0.426 and the standard deviation is 0.072. And then we repeat that 300 times again. Now the sample size increase to 100 every time, right? Now we can say that the mean is 0.42 and the standard deviation is 0.047. So based on the three histograms that we have so far, when we increase in the sample size from 10 to 50s and then to 100, we can see that the mean or the sample proportion, it gets closer to the population proportion of 0.42 or 42%. And then the standard deviation for those distribution gonna get smaller and smaller. So we have 0.116, and now it's going to be 0.072, and now it's going to be 0.047. So the standard deviation will get smaller and smaller, and the sample size n get increased. So that's going to be the conclusion that we have based on the three histograms. Now let's summarize it, right? So when we increase in the sample size n more and more, 10 to 50s and then to 100, the distribution is going to be look like it's going to be more and more bell shape. Yeah. So in terms of the shape of the distribution, the sample size, the size of the sample n increase. The shape of the sampling distribution of the sample proportion become approximately normal. Yeah. So it becomes more and more normal, so bell shape and symmetric. How about the mean? So The mean, yeah, so this is going to be the mean of the sampling distribution of the sample proportion equal to the P, which is the population. Yeah, so the mean of the sampling distribution of the sample proportion will be equal to the population proportion P, population proportion. Okay, so we can see, we can do, when we take a look at the three histograms over here, right? So we can see that the mean for the sample proportion gonna get closer and closer to the 0.42, which is the sample proportion P. How about the standard deviation? The standard deviation of the sampling distribution of the sample proportion will get decreased, and the sample size n get increased. Okay, so that's going to be the conclusion that we have based on the shape, based on the centers, and based on the spread of this distribution of the sample proportion. Okay, so let's summarize it. Let's see how we're going to use in the, how we're going to get the conclusion of this distribution of the sample proportion then. So how can we know that if the sampling distribution of the sample proportion will become more and more normal when the sample size get increasing forever? Okay. Let's take a look at the summary there. So the sampling distribution for the sample proportion P hat. So for a simple random sample subsize n with the population proportion P. Okay, so we have the sample size n and we have the population proportion is gonna be P. Okay, so we have the sample size n and then the population proportion is P. Now, the shape of the sampling distribution of p hat is approximately normal if this condition is true. When you take the sample size times it by the population proportion times 1 minus the population proportion p, if that product is more than or equal to 10. So if this condition is true, then we can say that the sampling distribution of the sample proportion will be approximately normal. So whenever we have a normal distribution, then we need to know the mean, right? So what's going to be the mean of the sampling distribution for the sample proportion? So the mean of the sampling distribution of the sample proportion P has is equal the population proportion P. So the means of P has equal P, which is the population proportion. How about the standard deviation or the spread of the sampling distribution of the sample proportion? Yeah. So the standard deviation of the sampling distribution P has is equal the square root of P 1 minus P over N. So this is going to be the standard deviation or the spread of the sampling distribution of the sample proportion. So the results of this is true if the trials are independent or the sample size is no more than 5% of the entire population. So you want to make sure that the sample, the individual in the sample, they're going to be independent, or the sample size is no more than 5% of the entire population. Yeah. So after we know that the sampling distribution of the sample proportion is approximately normal with the means of P and the standard deviation of square root of P1 minus P over N, then we can use the normal distribution that we learned from the chapter 7, right? So we can use the ideas of the normal distribution to calculate the probability. So the probabilities is going to be equal to the normal CDF lower bounds, upper bound, mean, and standard deviation. So the means of P has equal P, and the standard deviation of P has equal the square root of P times 1 minus P over N. Okay. So we might use the same idea from chapter 7, normal CDF, lower bounds, upper bound, mean, and standard deviation. Okay. So that's going to be the summarize of the sampling distribution of the sample proportion. Okay. So the condition is n times p times 1 minus p have to be more than or equal to 10. If that condition is true, then we can know that the means is equal, the means of the sample proportion equal the population proportion. The standard deviation of this sample proportion is equal the square root of p times 1 minus p over n. Okay. So that's going to be the distribution of the sample proportion. Now we're going to do some practice question, right? How we're going to use the summary to answer some of the probability question based on the sampling distribution of the sample proportion. So the first question we have is this one. So according to the census, the unemployment rate of the population in Orange counties is about 6%. So this is going to be the unemployment rate is about 6%. Now, suppose that we take a sample subset 200 individuals in the labor force from this population. So this is going to be the population proportion of unemployment rate. Unemployment is 6%. And from this population, we take a random samples of 200 individuals. Yeah. Now describe the sampling distribution of the sample proportion of OC individuals who are unemployed. Okay. So describe the sampling distribution. So whenever we describe the sampling distribution, you have to talk about the shape. We're going to talk about the centers and we talk about the spread. Okay. So when we talk about the shape over here, so what kinds of distribution is going to be? Is it going to be normals or not normal? Is that going to be uniform distribution? Is that skew left, skew right? That's what they mean by the shape of the distribution. So is it going to be a normal distribution? We have to find it, right? So is it a normal distribution? So based on the question, we know the sample size n is equal to 200. And we know the population proportion P is equal 6%. Or that's going to be 0.06, right? So I'm just rewrite the 6% in terms of the decimal, okay? Okay, so we have the sample size n is equal to 200. We have the population proportion P is equal 6%. Now I'm going to plug into the condition to double check if this condition is true. So I'm going to take the sample size n times it by population proportion P, 1 minus the population proportion P. Make sure that this calculation more than or equal to 10. So the sample size n is 200. The population proportion is the 6%, 1 minus 0.06. You want to make sure that this calculation have to be at least 10. Okay. So let's try it then. So we're going to get 200 times it by the population proportion is 6%, times it by parenthesis 1 minus 0.06. So 11.28, okay, that's good, right? So we have 11.28, which is more than 10. Okay, so this condition is true. So because this condition is true, so we can say that the sampling distribution of the sample proportion is approximately normal. Okay, so it's going to be approximately normal. Okay, so we just determine that the distribution will be approximately normal. So whenever we know that the distribution is normal, we need to show the mean or the center, right? So the mean of the sample proportion equal the population proportion. So the mean of the sample proportion equal the population proportion. Okay. So the means of the sample proportion equal the population proportion. And what's the value for the population proportion? We have the population proportion is 6%. Okay, so 0.06. So we got the means equal 0.06. How about the spread or the standard deviation? Okay, so this is going to be the formula to estimate the standard deviation. Is equal to the square root of P times 1 minus P over N. Okay, so now we know N, we know population proportion P, so we can plug in everything for this calculation, right? So this is going to be the square root of, on the numerator, we have population proportion, which is 6%, 1 minus 0.06% divided by the sample size N is equal to 200. Now let's estimate this calculation then. So second square root 0.06 parenthesis 1 minus 0.06, and then divided by 200. So I'm going to round this answer to 4 decimal place then. 0.0168. Okay. 0.0168. So this is going to be the approximation for the standard deviation. So the distribution of the sample proportion will be approximately normal with the means of 0.06 and the standard deviation is 0.0168. Okay. So that's a question A. Describe the sampling distribution for the sample proportion of OC individuals who are unemployed. Okay. Now, after we got the normal distribution, now we are ready to answer the next question in terms of the probability. So what is the probability? Okay, so what is the probability that the sample proportion is less than 0.35? So the sample proportion less than 0.35. So that is what is the probability that 0.35 is equivalent with 3.5%. So what is the probability that less than 3.5% of the sample of the 200 will be unemployed? So this is going to be less than 3.5%, right? So less, we're going to use in the less than notation. Okay. So the question asking what is the probability that the sample proportion p hat. Okay, where is it the p hat? Okay, right here. Okay. So what's the probability that the sample proportion is less than 3.5%, or it's going to be in terms of the decimal 0.035. Okay. So how we're going to answer this probability question? So based on question A, we know that the distribution will be approximately normal. So we know that the distribution will be approximately normal. The mean is 0.06 and the standard deviation is 0.0168. Okay. Now we are ready to answer this question. So because this is the normal distribution, so I will use the normal CDF calculation to answer this probability question. So we're looking for less than 0.35. So you might need to draw the normal curve and determine the lower bound. So less than 0.035. So which means that we're going to go from 0.035 and we go on the way to the left. Yeah, we're going to go to the left. So because we go to the left, so we're going to go to the negative infinities on the left. So the lower bound will be negative infinity. So negative 999. And then the upper bound, see the value where you stop 0.035. The mean of this normal distribution, 0.06. And the standard deviation is 0.0168. Okay. So the mean is 0.06 and the standard deviation is 0.0168. That's what we know from question A. Okay, so we just got the lower bound, the upper bound, the mean, and the standard deviation for the normal CDF calculation. Now let's give it a try with your calculator to see what's the answer there. Okay, so you gotta remember how we accept the normal CDF, right? So we're gonna go second vase, and then we're gonna go down to option number 2, normal CDF. So the lower bound is gonna be negatives infinities. Make sure that you're using the negative key, not the subtraction. The upper bound is 0.035. The mean is 0.06. And the standard deviation is 0.0168. Okay, 0.0168. Okay. We go down to paste. So double check all of the input that we have so far, everyone. The lower bound, the upper bound, the mean, and standard deviations. Yeah. Okay, double check one more time before we hit the enter key to get the answer then. Okay. So the answer is going to be 0.0684. 0.0684. Yeah. 0.0684. Okay. So that's the probability that the sample proportion will be less than 3.5%. Yeah. So that's the probability when you randomly selected a sample and then that sample have the sample proportion less than 3.5%. Yeah. So this is going to be about 7%, right? Yeah, so it's about 7% that you will randomly select the samples and that sample have the sample proportion less than 3.5%. Yeah. So this is going to be question number 2, an application of the sample and distribution of the sample proportion. Okay. Now we can try another one to make sure that you feel comfortable with this concept, right? Okay, so let's take a look up example number 3. So according to the census, again, about 10% of working population in Orange County carpool to work. Okay. If a random samples of 150 people, so if a random samples of 150 people who work is taken, what is the probability that at most 20 of them carpool to work? Yeah, so 20 of them carpool to work. Okay. So let's see how we're gonna answer this question then. So this is the proportion. So the question gave you in terms of proportion. We got 10% of the working population in Orange County is a carpool to work. So in this population, we randomly selected 150. So when you summarize this one, okay, so let's see what we got so far there. So we got the population proportion is the 10%. So what is 0.10? In addition to that, we also know the sample size n is 150. Okay. And then we're gonna get the numbers of people who carpool to work gonna be x. So x is equal 20. Okay. So that's gonna be the question then. Okay. So based on the question, that's what we know. We know the population proportion is gonna be 10%. And then we have the sample size n is equal 150. And then we have the numbers of people who have some certain characteristic gonna be 20. Okay. Now this is the proportion. So what kinds of distribution we're gonna get then? So you might need to double check, right? Okay. So it is a normal distribution. We're gonna check the condition, right? Check the condition. Yeah. So we need to check the condition for the normal distribution. Check the condition. Okay, check the condition. Okay. So what's the condition for the normal distribution? We have n times p times 1 minus p have to be more than or equal 10. Okay. So we know the sample size n is 150. We know the population proportion is 10% of 0.10. And we know 1 minus the population proportion, 1 minus 0.10. You want to make sure that this answer, this calculation more than or equal to 10. Okay. Is it? So now 150 times it by 0.10 times it by parenthesis 1 minus 0.10. Okay, so we have 13.5. That's more than 10, so that's good. 13.5 more than 10. Okay, so this is true. So because this condition is true, so we can say that the sampling distribution of the sample proportion is approximately normal. Okay, so the distribution is approximately normal. So when we know that this is a normal distribution, you have to know the mean. Okay, so based on the summary that we know the means is equal, the means of the sample proportion equal the population proportion. Okay. So the population proportion that we have either 10% or 0.10. How about the standard deviation then? Okay, so we have the formula for the standard deviation earlier, right? Okay. Okay, so we're gonna plug in the value, then it's gonna be equal the square root. Okay. So quotient. So the population proportion is the 0.10, 1 minus 0.10 divided by the sample size is 150. Okay. Now let's estimate this sample standard deviations, right? So second square root of 0.10 times it by parenthesis 1 minus 0.10 and then divided by 150. 0.0245. Okay, I'm going to round the answer to 4 decimal place then. So 0.0245. Okay, 0.0245. Okay. So based on the calculation that we just completed, right, we know that the sampling distribution of the sample proportion of OC people who come to who carpool to work is normal with the means of 10% and the standard deviation of equal 0.0245. Okay, so this is a normal distribution. Then we're gonna use the normal distribution to answer the question then. So this is, keep in mind, everyone, this is the population proportion. So in order to answer the question, you have to calculate the sample proportion. Everything have to be in terms of proportion. So this is, they gave you 20 people. So 20 people is not in terms of proportion. 20 of them. So at most, 20 of them. So at most, we can translate that as inequality later. But this is 20 of them. So this is not in terms of proportion. So 20 of what? So 20 of 150 people carpool to work. So we know X equal 20, we know N is equal 150. So you have to calculate the sample proportion P hat, okay? So you're gonna calculate the sample proportion, okay? So everything have to be consistent. So this is the sample proportion. So you have to do the proportion, right? So the calculation in terms of proportion, you have to keep everything in terms of proportion. Yeah. So we have population proportion. Now we need to know the sample proportion. So X gonna be 20 and then N is equal 150. Okay. So we're gonna get 20 divided by 150. Okay, 0.1333. I'm gonna use it for decimal place again, 0.1333. Okay. So at most, what does it mean by at most then? So at most would mean the maximum, right? So the sample proportion gonna be less than or equal that. Yeah. So the sample proportion gonna be less than or equal 0.1333. Okay. So at most is the maximum. Okay. So now we're gonna use the normal CDF. Now what should be the lower bounds and the upper bound? So at most is the maximum of 0.0133. So we're gonna go from that to the left or to the right. So at most is the maximum. So you cannot be more than the maximum, right? So you have to go from that value, 0.133 to the left. And then when you go infinity, when you go forever to the left, that's we're gonna approach the negative infinity. Yeah. So we go from negative 99999. The upper bound is gonna be 0.1333. The mean is equal 0.10. The standard deviation equals 0.0245. Okay, so that's gonna be the calculation. That's help you with the probability then. Okay, so now we're gonna use the normal CDF. So second was option 2, normal CDF. The lower bound is negative 9999. The upper bound is 0.1333. The mean is equal 0.10. The standard deviation equal 0.0245. Make sure everything is good, right? So the mean is equal 0.10 and the standard deviation 0.0245. Okay. Now double check the lower bound, the upper bound, the mean, and the standard deviation one more time before we hit the enter key to get the answer then. Okay, so the answer will be 0.9130. Yeah, so that's it 29 and the next one is a 5. I'm gonna round the 29 become 30. 0.9130. Okay, so this is gonna be the probability that at more 20s of the people, at more 20s of the 150 people gonna carpool to work. Okay, so that's gonna be 91%. Okay. So this is the second examples of the sampling distribution of the sample proportion. So you have to watch out if you're gonna use in the proportion, then everything needs to be in terms of proportion. Yeah. So sample proportion, population proportion, everything should be in terms of proportion. And the condition that you want to double check for the normal distribution for the sample proportion is N times P times 1 minus P have to be more than or equal 10. After this condition is true, then we can approximate the mean for the sample proportion, which is equal to population proportion. And then the standard deviation for the sample proportion is given by the formula square root of p, 1 minus p over n. So this is going to be the conclusion of section 8.2. I'm going to stop the sharing at this point. Okay, so I will stop the recording at this point, everyone. You might stop the recording also, right? And then go back and do the homework for section 8.2. I will see you next time for the next recording. Yeah.